So today I want to talk a little bit about what is better for us in new project. Should we use the ORM or SQL? Should we write plain SQL, or we should combine them together somehow? A little bit about me, but yeah, my friends sold me. So I'm a Ruby developer for some time. I collect tabletop games because it's not only board games, it's also card games. And at some point of my life, I worked as DevOps a little bit. So I might be a little biased for the databases and using them more in more spaces than usual, than normal developers do. Currently, I work at tabletop. They contacted me that I can go to pivorak, and here I am. So about the question of the presentation, what should we choose? At this year Wrocław RB, I heard that being a consultant is pretty easy because you can answer it depends. Because it really depends on your case. If you have a pretty simple application, you shouldn't go to the SQL because it will overkill you. But at some point, you need to decide if you want to still use the plain code or you want to do the database, the whole calculation to speed your application or not. It will be complicated for most of the people because not everyone knows the SQL maybe as good as you, but maybe it's the necessary step. But at the beginning, before you do something like that, or before you want to start something new at your project, it's really good to know your tooling, because even if you use the latest technology, when you use something that is cool right now, but you don't know how to use it, you can have problem because as we heard in previous presentation, there is no silver bullet in programming. There is no good tip how to do it every time. So you need to think about it, and you need to choose what is best for you, but what is best suited for your project. So who on this room knows SQL? Okay, most of the people, I won't boring you a lot. And who knows something more than pretty simple select with joins, update and delete? Who knows something more in SQL? Okay, so maybe you will find some interesting here. My whole presentation will be about 3 cases that I faced during my working, and each case has like start case, what we want to accomplish there, what was the problems what we faced, what was the benefits of the steps that we selected at the beginning, and some conclusion with some solution, and summary at the end, how it ends, because all of the cases went in the past, so right now I know what was the output of it, if it was good or not. So the first case was the simple project that do a lot of calculations. At the beginning, we know that most of the thing will be statistic calculation on the data. So it's not like simple CRUD application. We don't write a lot of data. We don't change them frequently. We just put the data in the database and show some result based on what we already have in database. And our case was, the whole statistic was about our projects. We use some issue tracker and we want to download data about it, because the data that we get from our issues tracker wasn't good for us for measuring different stuff. And all issues, as you know, have some status at this point, and we want to track the status changes. And we need to decide how we store the data, how we store the information about the status changes, and how we how you want to what will be our data that we want to process. So we started with something simple. We have some. I hope that this is understood for you. We created some table where we stored status changes for our project, and the main field here is the change at when the status change happened, because we want to store the event that some status changed. We don't want to store when the issue was in the status. We want to only store the event when it happens, because sometimes it can get messy to update the status. When we want to import all the data, it's easier us to just put information that at this moment of time the status changed from one to another. What was the good part of that? That when we want to update something, when we want to alter, because maybe our system wasn't working, maybe something stopped working, maybe the other service wasn't answering. It was that when you want to update this data, it was easy. You only need to change one record, and at this point, all data, we only need to alter one record instead of two, because when you want to change one end of the range, you need to update also the other record when the change happened. But our problem was how to get the status at some point of the time when we have only event when it happens at on some point of the time. We don't have ranges for that. We cannot just query that give me the issues at some point. So we started with a simple query to retrieve the status for the of this issue at some point. So we selected all status changes that happened before this time that we wanted to check. We ordered by it not alphabetically, and we selected only first row. So we have the latest change that we had about this issue. But this works only for one issue. We cannot query like this. We cannot query it for more than one record, because more for one issue, and that was the problem. At the beginning, our project was really small, and we can perform multiple queries for it, because making 10 queries for application that is used for like 10 people is not a problem. But when this grows, we want to make the whole company to use it, and that was the problem, because the performance wasn't good. So I do what I do normally in the programming. So I checked the documentation of the Postgres, and I found ranges. Do anyone heard about ranges before? Okay. Normally it works like in any language. So we can have integer ranges, we can have date ranges, we can have time zone ranges. There's a lot of them, and we can work with them like with object in Ruby. We can check if something is included in that range. We can check if the ranges overlaps with them. So, and a really good thing in that is the last line, because when you have null on the second end, it's from the beginning till infinity. So for dates, it's from now to the future. So, and this was really useful in some cases, because with the current statuses of the issues, we don't have ending date of the status for this range. So this was really good that it worked in that way. But yeah, we still stored only a start date of this change. So we only stored the event date when the status was changed. So I go back to the documentation and try to find something how to get previous record, maybe next record in the database, and I find something that is called window functions. Window functions is pretty useful if you know how to use them. It groups your query to to small groups defined by you. It works similar to group by, but in the result of your query you get all of the records, not grouped like with group by, because with group by you get unique record of values that you want to return. And we can do a lot of things with these windows. We can count minimal values, average values. Most of function that works with group by works also with window function, but we also can get next record, previous record, or any records that we really want from the list. So we use something like that. And the line about window function is here. The pointer is that we defined the window here, and we partition the whole result of our query by one column. And when I want to get the next record, it's only from this window, so I can group it by by issue ID. And in that case, I get only status of one issue. And I also set an order, but this is not required. You can even use one whole window for one transaction. And the let function allowed us to get the next record on the list. So with this simple function, I put both of the dates, the first date and the change of the next issue, to the to small range. And I ended with a table with a result that have start and end date of each status per issue. And everything worked fine at this point. It was pretty good because we cut a lot of the extra queries for each page, and when this was working fine, I decided to put it into view because it was easier to maintain in the future, to retrieve the data from the with the ranges and do not build the queries at any time. It was some simplification. For the people who don't know what is view in the database, it's you can save any query, any select query to view, and work with that like virtual, I would say, virtual table, because it's not real table, because every time you every time you want to get something from the view, it's executed. So it's not stored directly on the disk, but you can join to it. You can select specific columns from it, and it's pretty good to avoid some queries that you store a lot of that you use a lot in your code. But it sounds really good, but there is one problem. When you want to change the structure of the database, you can have a problem with that. So I would recommend to use it with caution, but our project was pretty simple. Our domain was simple, and we decided that we can use it. So I created the view. The definition for it is pretty simple. You only name the name that you will be using for your view. And I really like to add a namespace to it, so it won't interfere with my normal tables. I like to keep it into separate namespace. And with that view, I can easily query for current statuses. it reduces it to something like that. I don't need to do any distinct on the table. Don't need to order it. I only check which range is ending right now, which range include right now. And for the summary of this project, it was the small part that was the heart of everything, because we do all our statistics based on the data that we stored here. And when I wasn't working with that project, someone else started writing a lot of SQLs for it, because we started to using only SQLs here. It ended very badly, because when someone is not very familiar, they will try a lot of tricks from normal languages in the SQL. But it's easy to rewrite when someone writes a understandable that code that you can understand. And it ended well, I think, because a lot of times we had a problem with the broken data that we need to adjust. So choosing the field to store only one date instead of two was, I think, a good solution, because I did not need to change these dates in all records, only on this that was affected, and we did not have problems that some, as I will call, missing spaces for the times when something wasn't in some status. So I would say it was pretty good experience, and we use ORMs only for retrieving data. It was pretty simple thing. We just retrieve it as objects, and whole SQLs was written as plain, right? And I have case 2 for that, and it's I called it calendar, because our client had a problem and he wanted to create a tool for people that you can create appointment with. If there's barber or dentist, I'm not sure. This was his business idea for it. It was pretty a long time ago when such tools doesn't exist at all. It was like, I don't know, 7 or something like that years ago, and he has an idea that he saw it in States and he wants to create that. Calendars are not that simple as you can think, because you need to have normal availability, so you need to create your working hours, but there's also vacations and other changes, other exceptions for the availability. So for one day I want to work more hours, and for other day I want to work small number of hours. And when there's a lot of the people, then it makes more complicated to find someone who is free at some point. And we need to track all information about old meetings. We don't want to lose them, so we want to know when someone canceled that, because maybe we can reach to him and stuff like that. It was a lot of business logic around it. And we want to store it, we want to store all, we called it slot at this point. We wanted to store all slots in database. So we decided to generate all slots and remove them if there was some exception. So we generated it for the future. It was okay for our client. But in that case, it was easier because we have our start and end date. We don't need to manipulate a lot with that. But we have also some columns. And I know that this is not the best solution for it, but yeah, we started like that. We have only one column. After that, we added another one. We did not want a state for that. We only stated as booleans. So there was any problems or benefits of our solution? I'm not sure if we do it really right or if it gives us something. But the problems was problems happened later. So we started to selecting the slots, that are not collided with meetings. So we created meeting in databases, but creating a meeting won't delete a slot with database. So we need to select 3 slots, and we came with some idea like this to select the 3 slots. And with one line, I forgot to put it here. Okay, never mind. So we find slots that are colliding, so slots that are not available because the meeting is at their time, and we put it into not exists. And the problem was here that not exists is not very optimized. And I really don't know the database that handle really well the not exist queries, because you need to perform a query for every record that you want to return, and this is not very very efficient. So we started with something that is called partial indexes. It looks like normal index, but we can restrict some records to include in that. It works well with queries that use where, but almost all queries use where. So, and in our case, almost some part of the database wasn't used, so we don't use normally cancelled meetings and rescheduled meeting. We only want to work on not cancelled and not rescheduled meetings, so we can cut them off from most of the queries, because in every query we include this part. Almost all queries have the same where condition. So we created a simple index that just covers the main meetings that are not cancelled and not rescheduled, and it was a boost, because we don't need to filter them from the query. And after that, we also want to use something called common table expression, and this creates as we can think about this as temporary table that we can use for this query only. It's not stored on the disk, it's calculated on the fly. And like with views, we can use it as normal table. And thanks to that, we can create our queries a little better, because we can name some part of it as our, I would say, business, because sometimes it's really hard to understand what more complicated query looks like when you have like 30 lines of code in SQL. But there is also one problem: the planner won't optimize them. But normally, if you don't know what planner is, you probably don't worry about it and don't use CTA at all, because it's pretty related to, and you should know what is happening and why you want to extract it. And it ended with something like that, because we need to retrieve our data, and we put it into the common table expression to retrieve it easily, and we change it to this to optimize it. And in the end, we put it into view 2. So it was pretty good, and we used the views, and most of the code was in the database. So we still use our tooling in Ruby. We don't pollute our code with that. So in fact, we still use normal ORMs for that. And the last thing is about the application that we get at some point. There was a lot of legacy code, and the problem was the code itself, because it was poorly written, and the code was really, really bad written because there was almost no specs. So when you change something, you wait on someone to tell you that his feature is not working. And the structure of database was really, really, really bad. This is the part of it because the user table was really big. And I want to tell you about a couple of things that we do on that too, what was interesting. We add something called ctext. It's case-insensitive text. It's pretty okay because you don't need to worry on queries if you put everything in lowercase. Just when you query it, the case is not used. And the problem here was the task table, because the task has a JSONB table, and previous developer decided to put something strange here and avoid working with schema. So problem is obvious. It was something like that. There was status 1, name, selected, and value, and 5 times. 5 statuses, 5 different names, 5 different status for select. Some of the task has selected multiple, so a couple of them was selected, but this is a radio button, not a checkbox. And value was 1, 2, 3, 4, 5. It was nothing unusual. And the idea was that the project, not because the task has a project ID, task belongs to project, that the project has custom statuses, not each task. So he created something like this and store in every task that was related to this project the name of it, if it was selected, what was the value of it, and something crazy. And we have a big performance problem on some pages when we retrieve a lot of the tasks, and we retrieve all of this JSON. What we really want was one field that one status was selected, only that. We don't need the rest of it because the project knows about the statuses of it. And yeah, a lot of this data was in the query, and if you want to select some task with status, it was almost impossible in normal query because it was stored in JSON. So I started again with the documentation. It's a really good place to go. If you know what they're doing, just read the documentation. And I find something called auto-updatable views. So all views are auto-updatable if they use simple query. So when you have simple select for some fields, you can update them directly. So we decided to hide this ugly column and do the updates manually on the selected values, but we created something like this. So we selected name, project ID, and to do beautiful case to select only values that was useful for us. These two fields we were able to update them with normal query, but and our case changed that to status as a number based on the query, and the return was pretty simple because it was only 3 columns. There was no this ugly JavaScript JSON here. And in the end, we should do it in a little bit other way. We shouldn't start working on adding feature, but clients really want that. After 2 years, I know that the project is still worked on. There is no new version that was planned. So after 2 years, they still work with this code, and this is a problem, I think. And yeah, but it was really good experience for us. We can use a lot of custom queries for it, and we learned a lot about different techniques, how to optimize the code, working with legacy code. And one thing from it, always write aspects before you write with this legacy code if you don't have one, because we had a really good customers that they don't have a problem that something breaks. They only send us an email, okay, it's not working again, please fix. There was no pressure from them. They was familiar with that nothing is working on this application, but not every client is like that. And yeah, that's all. You can find me on Twitter. You can write to my email. Maybe I will read the email. But if you're interested in our platform, tabletop, you can contact me. You can talk with me later. I can give you some information. But yeah, that's all. Okay.
Add 5 new codes and migrate all the data via one SQL.
Yeah, and the problem here, I understand. In the last one was pretty tricky because we cannot change the schema easily, because there was some something called something to synchronize mobile apps. So we allow to mobile apps to store data on our application, and they worked on the old schema. The migration of it will be very painful. So we want to create some models for us to work with this code, to learn this application before we want to destroy them with non-damaging way. So we just want to try to start working with that, knowing what's the problem. Maybe this structure was good. No, it wasn't good. Yeah, the migrating data at some point is really good, but in the last case it wasn't possible because some third party was able to send us data. We need to write a lot of stuff for them to change the data on the flight that was stored in the database. It wasn't also a good process. The process has a lot of bugs, but yeah. One of the idea is to rewrite migrate the data, but sometimes it's not that simple when not only you depends on this database, because maybe you have a shared database and between projects and you cannot change the database easily. You can create a view for you and work with that you have. I'm not sure if this answers your question. With time zones? In which case?
In all of those,
Time zones are pretty bad, but when you use range time stamp time zone, you work with a time with a specific time zone. So you store the value of this time zone with time zone in the database. And when you query, you need to provide the time with time zone for it, because now function in SQL returns timestamp with time zone. So every example in this presentation has time zone included into that. It's one of the way how to handle the time zone, but if you really want to talk about time zone, it's really big. It really takes time to talk about it, so we can talk about it later more.